Alright, so day 2 on ellipses, just a few more things using ellipses. Now keep in mind that this is sort of our reference here. Alright, here's the general form of the equation for any ellipse. This is just an x squared over a squared and a y squared over a squared if it's centered at the origin, which most of ours are. And then remember, the definition of an ellipse is this distance plus this distance. So the distance from one focus to any point on your ellipse plus the distance to the other focus, it always adds up to be a constant. Those always add up to be a constant. We're going to use that in a little bit. So writing an equation in graphing form of the ellipse. So we need a certain minimum amount of information, and what we're going to need right now is to know where those endpoints are, or those vertices. So we call this the vertex of our ellipse, or these are the vertices. So remember that those are from the center, and it's easy to see that the center is at 0, 0. This is 6 units, and that is our A. From here to here is the length A, from the center to the minor, half the minor axis, or the center to the closest edge is B. So A equals 6, and this is B, and B equals 4. Therefore, we can easily write this equation. Its center is at, our general form of the equation is y minus, no, x minus h all squared over a squared plus y minus k squared over b squared equals 1. So our coordinates of our center are these, and that's a 0, and that's a 0. That should be squared outside, my bad. And then the a squared, the a is 6, our b squared is 4, or b is 4. So this simplifies to x minus 0 is just x squared over 6 squared is 36, plus y minus 0 is the same as y squared over 4 squared is 16 equals 1. So that's the final answer. Pretty easy to get the equation if you know the vertices. Alright, so write this equation graphing form of an ellipse having the intercepts these. So they don't tell us the, again, they tell us the vertices. So if we are to look at the graph, let's kind of throw up a quick little graph here. Now, the intercepts are root 7 plus or minus root 7 plus or minus root 3. Since they're both equidistant from the origin, so it's negative 3, that's 3 for our x-intercept. Since they're all equidistant from the origin, we know that the center has to be at the origin, so that makes it easy to find our equation. And then, now, is root 7 bigger or less than 3? Well, think, what's the square root of 9? The square root of 9 is 3, so the square root of 7 has to be smaller. So I'm going to say that's exactly root 7 right there. And I'm sorry for the writing isn't quite as good as normal, or it's worse than it normally even is, just because of the technology I got to deal with today. So there are our vertices. So our ellipse is like this, yikes, and our foci are going to be on the x-axis because you can see that this distance is longer. From here to here is 6 units, and from here to here is less than 6 units. So this is our major axis along the x-axis, means our foci are going to be on the x-axis. And now, since we know that we know our A, we know our B, whoops, our A is 3, our B is root 7. So all we need is the center, which is the origin, then A and our B, and we can write our equation. If you needed to find the foci or the focuses, you would use the relationship that c squared equals a squared minus b squared, and then you could plug those numbers in and solve for c. and then move it that many units to the right, that many units to the left, and that will give us the foci, or the two, each focus of our ellipse. So we got A, we got B, and we know the center is 0, 0, because it's centered at the origin. So this is easy. It's x minus 0, or just x squared over a squared. So that's 9, plus y minus 0, which is just y squared, and then b squared. So if I square square root of 7, that gives me just a plain old 7 here. And then we have to set that equal to 1. So there is our final form of our equation for the ellipse. All right, now this next one's a little bit more intense. There's a lot more going on with this one. So they give us the foci. That's 7 and -7 on the x-axis. Okay, and now they tell us that the focal radii, or the sum of the focal radii, is 50. So that means they're talking about the sum of these distances here. This distance plus this distance equals 50. So for us, this plus this has to add up to 50. All right, so this is just an arbitrary point on this graph. What I'm going to do is, since this is true, my bad, this is true for all points on the ellipse. Doesn't matter what point. I'm going to pick the special point that is equidistant from both focuses, or both foci. Really, what it is, it's going to be on the minor axis, and that's going to allow us to use what we know about B and C here. So we know, since it's centered at the origin, or these foci are equidistant from the origin, this is the center. All right, so that tells us that, that tells us that this C equals 7. All right, so we know C equals 7, and then I'm going to pick, this is not going to be to scale. In fact, I've already done the problem, so it's way not to scale. But we're going to say that, let's say the ellipse is somewhere up here. This is our point on the minor axis. So we got some vertex out here, equidistant down here, and then we have the vertices on the major axis. All right, well, since we know that, what do we know? Oh, yes, we know that this is some distance b. From here to here is b. And we just said from this slide that if I add up this distance and this distance, that has to be 50. Well, I picked a place where those distances are the same. So I know that if this plus this is 50, then one of these is half of 50, is 25. All right, now I know C, I know 25, and all I got to do is find B. Now it's just a simple Pythagorean theorem. So I have b squared plus, plus 7 equals 25. Nope, 7 squared, my bad. So then we have, 25 squared. Yikes. All right, so now we have b squared plus 49 equals 625, and now we're just crunching the numbers. B squared equals, subtract 49 from both sides, gives you 576. So b equals the square root of that, and the square root of that is 24. All right, so now I know my b, and remember I need to know my center, my a, and my b to be able to write the equation. So now that I know that, I can use that relationship of c squared equals a squared minus b squared. All right, so we know that also from our reference. This is always true here. C squared equals a squared minus b squared, where a squared is always the larger. And we know that our a, our distance from the center to this vertex, is this one, not that. We know the major axis is on the x-axis. So here we go. We got a squared c squared equals a squared minus b squared, plug it all in. So we just said that c squared was 49, that b squared was a 576. And now we're actually just adding the two numbers that we subtracted before. So add 576 to both sides, you get 625 equals a squared. So 25 equals a. So now we have everything we could possibly ever need to know, at least at this point in our mathematical careers, about this ellipse. So to finish writing the equation, we're going to use y, or x minus 0 squared is just x squared over our a squared is 25 squared. Come on. And then plus y minus 0, which is just y squared over b, which is 24 squared, equals 1. So that simplifies to x squared over 625 plus y squared over 576 equals 1. And that is the final result. That is our answer. All right, so now you got to go and do that worksheet number 4 that corresponds to this material. 3 types. Given the foci and focal radii sum, given the intercepts, or given the intercepts graphically. Basically, these two are essentially the same question. So here is your reference if you want to leave that open on your computer while you look and do worksheet number 4.